Good morning, my student. As you can see, here I already wrote a question about the bearing capacity of foundation. In this paper, you can see a square foundation is 1.5 meter multiple 1.5 meter in plan. The soil has a friction angle 22 degree with the C action 16 kilonewton per meter square. The unit weight of soil equals to 20 kilonewton per meter cubic. Determine the allowable gross load on the foundation with the factor of safety equals to 2.5. Assume that the depth of foundation equals to 1.7 meter. First, if we want to find the bearing capacity of the foundation, we have to know this is it said that the foundation is a square shape. It means that we have to find the bearing capacity of foundation for square shape. And in this section, we have to find the allowable gross load. So to calculate the bearing capacity, first we have to write the bearing capacity formula for square foundation. It equals to 1.3 CNC plus K multiple N K plus 0.4 gamma multiple B multiple N gamma. In this question, it said that friction angles equals to 22 degree. So for friction angle 22 degree, it said that the NC equals to 22.27 and the NK equals to 9.19 and the N gamma is 5.09. All these parameters you can find in table Terzaki. So we can calculate the bearing capacity 1.3 multiple 16 multiple NC 20.27 plus K. To calculate the K, it said that K equals to gamma of soil multiple the depth of foundation. So here we can calculate it. We have to find the gamma, the unit weight of soil is 20 and the depth is 1.7. So here we can write the 20 multiple 1.7 multiple 9.19 plus 0.4 multiple 20 multiple the B. It said that this is the value of B 1.5 multiple 5.09. So in this section we can calculate it. It's equal to 795 multiple 156 kilonewton per meter square. This is the bearing capacity of this foundation. But in this question, it said that we have to determine the allowable gross load. So the allowable gross load per unit area is equal to KU per safety factor. So here we can say that it said that the safety of factor is 2.5. So here we can calculate it 795.156 per 2.5. So it's equal to 318.06 kilonewton per meter square. So the total allowable gross load is K 318.06 multiple 1.5 multiple 1.5. So it's 215.664 kilonewton. This is the total allowable gross load. Last week we already learned about effect of water table. So in this section I will show you how to design or how to calculate the bearing capacity of foundation if the water table is known. As you can see in this paper, I already wrote a question. Here it says that a strip footing of width 3 meters is founded at a depth of 2 meters below the ground surface. The soil has a C equals to 30 kilonewton per meter square and angle of shearing resistance equals to 30 degrees. The water table is at a depth of 5 meters below the ground level. The unit weight of soil equals to 18 kilonewton per meter cubic. Determine the A. Ultimate bearing capacity, B. Net bearing capacity, C. Net allowable bearing pressure. So we can calculate it first. If you found a question like this, as I said before, as I said when I taught you how to calculate the bearing capacity, first we have to draw the foundation. So here I will draw the how will be the foundation. It said here that the width of foundation is equal to 3 meters. So it means the width is 3 meters, and it said that founded at a depth of 2 meters, and it means the depth of foundation equals to 2 meters. And it says the soil has a C is equal to 30 kilonewton per meter square, and the friction angle is 30 degree, and the unit weight of soil equals to 18 kilonewton per meter cubic. And it says the water table is at a depth of 5 meters below ground level. Because our ground level is here, it means the 5 meters, I think it's here, it's 5 meters from the ground level. It said that this is a water table. And then first we have to determine the ultimate bearing capacity. So the ultimate bearing capacity is equals to C and C plus unit weight of soil multiple depth of foundation multiple N key plus B and gamma, as you can see in this paper. First, it say that the cohesion is 30 kilonewton, and NC, yeah, we have to find NC, NK, and gamma. For V 30 degrees, it say that NC equals to 37.16 and key 22.46 and gamma it said that 19.13. So we can substitute the value to this formula. And the depth of foundation is 2 meters, and N key is equal to 22.46 plus half, and the unit weight is 18, width of foundation is equal to 3 and gamma is, so if we calculate this, it's equal to 2439.87 kilonewton per meter square. So this is the value of your ultimate bearing capacity. To calculate the net bearing capacity, it can be calculated from the ultimate bearing capacity minus the overburden pressure or key accent 0. The overburden pressure, it said that we can calculate gamma multiple the depth of foundation. Here, for the value of gamma, as you can see in our PPT, if the value of the D, this is D, the value of D is smaller than the width of foundation, it said that we have to use the average unit weight of soil. But if the value of D is larger than the width of foundation, we use the gamma is the unit weight of soil. So as we can see here, the value of D is equal to the width of foundation. So we use that the unit weight is the unit weight of soil in this question. It's equal to 18 kilonewton per meter cubic. So we can calculate it is 18 multiple the depth of foundation is 2. It means 36 kilonewton per meter square. So to calculate the net bearing capacity, it's 2439.87 minus 36 is equal to 2403.87 kilonewton per meter square. And in this, and for the point C, we have to find the net allowable bearing pressure. Q and A, we can calculate it by divided the net bearing capacity with safety factor. As I told before, in the question, it said that the safety factor is equal to 3. So here, the net bearing capacity is 2403.87 per 3 is equal to 801.29 kilonewton per meter square. So this is the net allowable bearing pressure.